step response testing system. Our members are Monty Bill, Sarah Rogers, and TJ Hurlis. A simple outline is we're going to talk about a background, then we're going to go into a steady state operation curve, we're going to go into the step response, and end with the resulting conclusion. Simple background.
Sweet. Y'all notice that? That's sweet.
What? Awesome.
Back up one. Pay attention. Huh?
Let's see it again. Alright. For a simple block diagram, we've got our input motor power, which is represented as a percentage, and it's the manipulative variable. Our output is the control variable, which is drive speed, which is measured in RPMs. This is a simple diagram of what our aerator mixer actually is. We've got a motor that goes into a gearbox, which has a 101 gear ratio, and then it in turn mixes a mixer, inputting into the wastewater outlet.
Can I stop you here? Did y'all know what happened yesterday out there at the mixers at the wastewater treatment plant?
Power outage.
Power outage, the huge 10,000 volt line fuse blew. And so they couldn't process what they ordinarily process. You know what their #1 product is out there?
Corn.
Our #2 product. I said that wrong. You know what their #1 business is? It's our #2 business. But anyhow, they ordinarily process 400 million gallons a day of stuff. And yesterday they couldn't process that for a while. And so guess what happened to it?
We got backed up.
Yeah, went into the river. So many of you thinking about taking that boat down the river at the aquarium. Anybody done that yet? Well, how was it?
It's pretty cool.
Yeah, but don't go today or tomorrow, okay?
Watched it from,
Which day?
watched it from another boat.
All right, go ahead.
I'm glad you're making this not so boring. So, like you said before, the wastewater treatment plant located in Chattanooga, Tennessee, is kind of what we're representing. They have these aerobic bugs that eat the waste, and they need oxygen to live, and that's what the mixer in favor does, give them oxygen. And this is regulated by the United States Environmental Protection Agency and the local and state pollution control agencies. Like I stated before, it's a 100-to-1 gear ratio. And so if you want the desired speed of 2 to 15 RPMs, you actually have to speed it up to 200 to 1500 RPMs. This is a sample of our 55% motor input. As you can see, the green line is the input, and then the red line is the output. We got about 951 RPMs with the ratio tolerance in between plus or minus 5.3 RPMs. This is our wonderful steady state operating curve. It's, as you can tell from the testing range of 5% to 95%, it's completely straight. There's nothing too awesome about it. It's the same way going down as well. And our slope was 17.6 RPMs per percent. This is an example of a step response. As you have the input percent jump, right here you have the output percent jump for RPMs. This is our 55% step response. We started out with 5%, jumped it up 55%, jumped it up to 70%, and we've got this nice little step right here that goes from about 990 to about 1200. And from that we can find the dead time and the time constant with our delta C and delta M, and our gain to equal up to be 16.7 RPMs per percent. From our average gain, you can see that it's kind of pretty linear. Not too tolerant, not too awesome like everybody else is, kind of going up and down. We've just kind of got simple. Nothing too extravagant with the error bars or tolerance levels. And then our average dead time was pretty close. I mean, it really didn't difference from 0.02 of a second, so it's pretty constant there. And our average time constant kind of went up right here. But like I said before, it's only 0.2 difference, 0.02. So our step up was from 5 to 95% with the average gain of 16.9 RPMs per percent. Our average dead time was 0.18 seconds, and our average time constant was 0.11 seconds. It's basically the same thing for the step down, except for 95 to 5%, and our gain was, of course, a negative.
The last thing he said, ignore that. The gain is not negative when you step down. Delta C is negative and delta M is negative. If you divide the negative by negative, what do you get?
Positive.
That's me.
And I, imaginary.
Oh,
Trying to liven up is a little boring.
yeah.